In this video, we are going to go over alkenes. So alkenes are unsaturated hydrocarbons that contain one or more carbon-carbon double bonds. This includes straight-chain alkenes, branched alkenes, and cycloalkenes. Remember, alkanes are saturated hydrocarbons. Alkenes are unsaturated. They have the formula CnH2n, where N is equal to the number of carbons. The molecular geometry of carbon centers in the double bond is trigonal planar. And so they have 120-degree angles between them. You can see the double bond is represented here by two parallel lines. So alkenes, a two-carbon alkene is called ethene, or you might see it as ethylene. It is produced by ripening fruit and it's used to make polyethylene. Propene, or three-carbon alkene, or propylene, is used to make polypropylene. As you can see, like our naming with alkenes, the prop is the prefix meaning three, eth is a prefix meaning two, our Latin prefixes. Here's an overview of different alkenes with different number of carbons. We have ethene, propene. Once we get to carbon number 4 and higher, we need to start putting a locator number in front of the name to show us where the double bond is. And we'll go over naming in later on, but that shows you where the double bond is. So drawing alkene structures, you can see that the skeletal line structure of 1-butene is you just have the double bond as two parallel lines in your skeletal structure. The condensed structure is you just read it as you normally would from left to right. You have a CH2, CH, CH2, CH3. Or you can write it as CH2 with the double bond or the two parallel lines, CH, CH2, CH3. There are different types of alkenes. There's something called a diene, which means that it is an alkene containing two carbon-carbon double bonds within the molecule. A polyene is an alkene containing more than two, so several carbon-carbon double bonds within the molecule. Fruits, vegetables, spices, and many other natural products contain polyenes. So this is beta carotene. On the right-hand side, the C40H56, you can see how it has multiple double bonds in here, carbon-carbon double bonds. It is a molecule that helps give carrots, tomatoes, and other brightly colored fruits and vegetables their distinctive color. So for naming alkenes, first you count the number of carbons in the chain and assign a name according to the proper Latin prefix and add the ending "ene." So alkene has an "ene" ending. For a cycloalkene, you count the number of carbon atoms in the ring. You name it according to the proper Latin prefix. You add cyclo to the beginning and "ene" at the end. For a straight chain alkene, make sure you number the carbon chain starting from the end closest to the carbon-carbon double bond. Add a locator number to the beginning of the name, followed by a hyphen to indicate the first carbon in the chain that contains the double bond. No locator number is used for an unbranched cycloalkane. So in this example, we have 1, 2, 3, 4, 5, 6 carbon chain, which is hex. There's a double bond within it, so it's an ene, and the double bond starts on carbon 2. So we have a 2-hexene. It's between carbon 2 and 3, but we do not put it as 3. We start with the lower number. We also number the carbon chain so that the number for the double bond has the lowest number. So we would not go right to left. We would not number it 1, 2, 3, 4, 5, 6. If we numbered it right to left, then our carbon, the first carbon that our double bond was on, would be carbon 4 and not 2. And that is a higher locator number, and we want a lower assigned number. So here we see that we have one hexene. We have a 6 carbon chain again, and our alkene, our carbon-carbon double bond, starts on carbon 1. So it's 1 hexene. When there's no substituents on a cycloalkane, it's just cyclopentene. So you have your cyclo, this is a 5 carbon, so 1, 2, 3, 4, 5. Pent, cyclohexene. You have 6 membered ring with a double bond, so you have your ene, and there's no substituents. So it's cyclohexene. So write the skeletal structure for 2-pentene. So pause the video, and when you're ready, we'll do it together. So for pent is the prefix for 5. Ene means there's a double bond. The 2 means that there's a double bond at carbon 2. So I am going to do my 5 zigzags. So this is 1, 2, 3, 4, 5. And on carbon 2 is where I start my double bond, and it goes to carbon 3. So that's 2-pentene. Then what's the IUPAC name for each of the alkanes below, or alkenes below? We have 2 carbons, which is eth. It's a double bond, so it's ene. There are no substituents, so it's just ethene. We don't need a locator number because it's not 4 carbons or more. Here we have 1, 2, 3, 4, 5, 6. 6 carbon chain, which is hex. There's a double bond, so ene. We have 6 hexene, and we have it at carbon 3 is where a double bond is. Now let's see what happens when we number right to left. If we do right to left, we have 1, 2, 3, 4, 5, 6. If we number right to left, our carbon-carbon double bond starts at carbon 3 again. It does not matter if you number right to left or left to right in this case, because the double bond starts at carbon 3 each time. So the name is 3-hexene. So alkenes contain 1 or more carbon-carbon double bonds, which are carbon centers with the trigonal planar geometry and have 120-degree bond angles. A double bond is represented by 2 parallel lines in the skeletal line structure. And alkenes are named according to IUPAC rules for alkanes, except the ending is changed from an ane to ene, and the locator number is added for the beginning of the name, at the beginning of the name, to indicate the first carbon in the chain that contains the carbon-carbon double bond. And the chain is numbered so that the carbon-carbon double bond has the lowest number assigned to it.